Aloha.
Aloha.
I know. Yeah, I try. So hi guys, my name is Kate Kramer. If you don't know me, I teach geology on campus, and I'm assuming you're here because you've been super excited over the last several months, as I have been, about all of these cool Hawaii things that have been happening. So I was asked to come and give a little talk about what's going on in Hawaii, and I'm going to start today by teaching you guys a little bit about Hawaii itself. So I apologize. I know Kim Hankins probably could get up and give some of this lecture because she knows a little bit about Hawaii. She's been in my Geology of the National Parks class. But I want to give you guys a little bit of background so that you understand why Hawaii is doing what it's doing. Because, you know, if I just stand up here and show you cool volcano pictures, you'll ooh and ah, but what I really want you to understand is why it looks the way it does. So I've got lots of fun volcano stuff to show you today. Give you a little bit of background about myself and my knowledge of Hawaii. I actually got to participate in a field trip. I was a co-leader of a field trip with a different college, and we actually took 18 students down and took them across all of the Hawaiian Islands and kind of explained to them some of the geology. I have a really good friend who actually works for the Volcano Observatory on the top of the volcano, and Mike actually gave me some of the input and cool stuff that you'll see in here too. So Mike Holland is a good friend of mine who works on top of an active volcano, which is really cool. And the other thing, you'll hear funny little weird references kind of throughout this. If you saw the title for this, it's Ikiloa, and Ikiloa is the Hawaiian term for the value of learning, so that's kind of fun. I looked it up. They have when you go to Hawaii, they have all of these gorgeous sayings in native Hawaiian, and they have lots of vowels, so you learn how to speak all these weird words. And you'll also see just something that you learn naturally. What we do learn a lot about in Hawaii is the goddess of the Hawaiian volcanoes herself, which is Pele, and you'll see some references to Pele kind of throughout this presentation because the native people of Hawaii take Pele very seriously, and we'll kind of talk about that a little later. So she is the goddess of the volcano. And I was watching CNN tweeted out this photo the other day, and I just had to laugh about it. So, you know, you've seen all these cool images, you've heard all of this interesting stuff about what's happening in Hawaii, and the big eruption basically started early May of this year, and it's continuing today, so we'll talk about where it's all gone. And the interesting thing that my students always ask me, or people always say, well, why can't they just like put up you know, cement blocks and things and block the volcano and just stop the lava in its place? And the sad thing is there's just no way to stop lava, guys. This old man, he said stop, and the lava just wouldn't stop. So we're going to talk about why that is. But before we can get into Hawaii specifically, I want to talk to you guys about why volcanoes exist, because, you know, lots of people don't really know exactly why volcanoes exist. My students often tell me it's because we're riding around on this molten ball of fire, which is not true. Actually, I know, it hurts my feelings too. But guys, the Earth, in fact, is mostly solid. A lot of the material beneath our feet is a solid that kind of behaves like a plastic. So that stuff that you see labeled on there, lithosphere, asthenosphere, mantle, all of those things are solids. The asthenosphere and the mantle are solids that behave more like plastic. So again, sad thing to learn today, we're not rolling around on this ball of fire. So the question always comes, okay, but there's volcanoes. So where is the molten, right? Where is the liquid stuff coming from? And we've got a couple of places where volcanoes exist that this happens. So a divergent plate boundary, this is a place where our two plates actually pull apart from one another. And at those places, we see the pressure released. So we take the pressure off the lithosphere, and then it allows it to melt. So it's kind of just a pressure release situation. That material has pressure taken off of it. That allows for melting. So we see volcanoes at divergent plate boundaries, places where two plates pull apart from one another. A really good example of that would be the East African Rift. In East Africa, we see this plate actually pulling apart, and volcanoes kind of fill in the gap. You're probably more familiar with convergent plate boundaries, where two plates slam into one another. One plate will actually subduct, slide underneath the other plate. And as that plate does that, it brings a lot of water into the asthenosphere. And that water that's coming into the asthenosphere hydrates the asthenosphere and allows for melting to occur. So we call that hydration melting. We basically make magma at those places. So the Cascade Mountains, Mount Rainier, Mount St. Helen, those are all associated with that convergent plate boundary. So two plates coming together and we get magma that way. Now those volcanoes generate big explosive eruptions, which we're going to talk about in just a second. Go ahead, Beth.
I don't understand where the heat comes from.
The heat?
The heat that's melting this stuff.
The core. The heat that's actually doing that is the core.
So at that distance?
Yes.
All the way through the lower mantle?
Okay.
If we go down about, let's say we went down about 10 kilometers into the Earth's crust, we'd be at about 500 degrees Celsius.
Wow.
Okay, so
The pressure gradient, or the temperature
everything
gradient
is
is,
really hot inside the Earth.
but not hot enough to melt it.
But
the pressure is high.
keeps it from melting.
Yep.
So as soon as the pressure releases,
Then we get melting.
then it melts.
Yep.
Huh.
You lunched and learned.
Well, I mean,
I know. I'm feeling pretty good. Class dismissed. Bev got it. We're good. All right. So just to mention, again, convergent plate boundaries. So what we typically see, a lot of the volcanoes that you guys are familiar with on Earth's surface are associated with that. And I'm going to come back and talk about those in just a second. But the last place that we see volcanoes existing on Earth's surface is at these weird things called hotspots. Now, the one big distinction I want to make to you guys is that hotspots are not a type of plate boundary. That's a big thing. So divergent plate boundary, placed between two plates. Convergent plate boundary, placed between two plates. Hotspots are these weird things that basically pop up in the middle of plates. And there are several hotspots that exist on this planet. Most famously, Hawaii is one of them, located basically in the dead center of the Pacific plate. But you might be more familiar with Yellowstone. Yellowstone is also a hotspot. So a lot of the stuff that you're going to see today dealing with the hotspot, we could apply to Yellowstone as well. Slightly different because in Hawaii, we're melting through what's called oceanic crust, and in Yellowstone, we're melting through what's called continental crust, so two different crusts that we're dealing with. And thinking like that, when we see the eruptions, so in Hawaii, at Hawaii volcanoes, because it's melting through this oceanic crust, it's tending to be very low in the mineral or in the element silica. Now, not terribly important other than for you to note that because we've got not a lot of silica, the magma tends to be really fluid, really runny, like water. In contrast, when we melt through high silica material, continental crust, we tend to get high silica magmas, and guys, high silica magmas go boom. They're very explosive. So when we think about the eruption of Mount St. Helen, which I can reference with you all, which I can never reference with my students because they've never, Mount St. Helen? I don't know what you're talking about, Kate. But I'm certain many of you can remember back to the Mount St. Helen eruption. Some of you may have even lived out in that area, Bev Dow. I know.
I climbed it.
And so, again, big explosive eruptions. So there's a big difference here when we talk about these two different types of volcanoes. And again, someday I can give a lunch and learn on big explosive volcanoes, and I won't go into those too much because we're more concerned about the Hawaiian volcanoes where we get these beautiful fluid lava eruptions. So this is a photo from the Hawaiian eruption, and you can see that lava, and we call it lava. That's the name for fluid rock that has erupted out onto the surface, flows just like a river. You may, and if you've been watching the news, you may have seen what's referred to as spattering, and in some of the videos I've got for you today, you might see some spattering happening. Sometimes this lava gets a little gassy. We all know how that feels, right? And sometimes we get spatter out of it, but it's still a very fluid lava. It doesn't explode like what we would see with Mount St. Helen. So because this lava is very fluid, it tends to build what are called shield volcanoes. And they're named as such because they look like big shields that have been laid out across the landscape. And so many people look at Mauna Kea, this is on the big island of Hawaii, and say, well, it's not a volcano, right? Because in your head, you think volcanoes are these pyramid-shaped peaks. Well, Mauna Kea, Mauna Loa, Kilauea, all the volcanoes that we see throughout Hawaii are actually these broad, domed shield volcanoes. They don't have really steep sides. They have this kind of more gently sloping side. And guys, that's directly related back to that fluid lava. So the lava here can flow for tens of miles from the vent, and it creates this big domed feature that we see. So we tend to get these beautiful shield volcanoes out of that. And just to kind of think again scale-wise, 10 to hundreds of miles in diameter, but the slope on them is pretty low grade, so it wouldn't be a terrible hike to hike all the way up to the top of it unless you started at sea level or something like that. So we like to think of them as these big shields, and the food, I always associate all cool things in geology with food, and I apologize guys, but vanilla wafers are what you need today. This is why I have food.
I think it'd be excellent if you brought some vanilla wafers.
Yeah, I really understood.
So I will tell you that there is normally, at this point, and Kim can vouch for me here, that I do bring food in. Here's the thing, I didn't buy a box of vanilla wafers because I thought there was literally going to be 5 people in the room and I'd be doling out like, here are your 6 vanilla wafers for all of this. So again, those nice big shield volcanoes that we're looking at. And then just for comparison, guys, this is Mauna Loa. This is on the same big island of Hawaii. This is kind of the sister to Mauna Kea. But you can see that broad dome shape. Yes, the white stuff on top of it is snow. That sometimes weirds people out, but Mauna Loa is at such an elevation that it usually is snow-capped. And then, again, you can see that, that dome shape. The little white peak that you see inside of there, that would be Mount Rainier, comparable to Mount St. Helens and things like that. So, again, big broad dome shape, not that pyramid shaped peak that we see, and it all goes back to that lava that we're looking at. So do want to mention to you, I said that the big island of Hawaii is actually made up of several of these shield volcanoes, and I have this really cool map that I know it's dark in here, but later on, if you want to come check it out, this is the big island of Hawaii, and you can kind of see these little dome shapes on it. All of those little dome shapes are all different shield volcanoes that have grown over time. And so the eldest is actually up in this corner, and this is Kohala. And then the next one down is Hualalai, that sits right here. And then Mauna Kea is here, Mauna Loa is here, and our current place, our current eruptive volcano is actually Kauai, Kauai. So we're actually sitting down. Where am I? I've lost myself. Hold on. Kilauea, there we go. I'm thinking other Hawaiian islands. Kilauea is sitting down here. We're going to kind of focus in on Kilauea. But the island itself made up of several different shield volcanoes. So there's about 5 different shield volcanoes that we're looking at just on one island alone. And go ahead.
All that flat land around it is all formed by some of these volcanoes.
Yep, and the other thing to remember about this is that these are highly erosive. And so, like up here, Kohala, you'll see these big canyons that have been eaten into the side of the volcano. So it probably at one point in time was much taller, and erosion has kind of flattened it out. And that's why Mauna Loa, Mauna Kea sit big and tall, because they're the most recent and they've seen the least amount of eruption on them. So that's why you don't see all of that eruptive stuff, if you will, on them. So we are looking at those 5 different volcanoes that sit there. And as I said, what's triggering all of this is that hotspot. So going back to kind of, a lot of times people ask, hey Kate, why is there a hotspot? The truth of the matter is we have no idea why there's a hotspot where it sits. Hotspots tend to kind of show up and are present for certain periods of time. The Hawaiian hotspot, which you'll see in a little bit, it's been around for at least 81 million years. So it's an old hotspot. It's been doing its thing for quite some time. In comparison, if you were to look at Yellowstone, Yellowstone's only been around for about 22 million years. So that hotspot is relatively young in comparison. So the magma that we're seeing erupting, go ahead, Rosalie.
Does that have anything to do with, I think they're called magma tubes?
Lava tubes. Are you thinking lava tubes? Is that what you're thinking? Give me a little bit. Towards the end, we'll come back, we'll talk about lava tubes. But lava tubes are more small scale on the island themselves. And when we think about this hotspot, I'm talking about a plume of magma the size of this island that's making its way up. Huge plume of magma. The other reason I put up this image, I want to show you guys Lauihi is on there. And you might say, I don't recognize Lauihi. In about 1 million years, Lauihi will be the next big Hawaiian island. So start buying property now. No, just kidding. Lauihi is actually on the sea floor and is building up. They've actually taken submersibles down to check out Lauihi. So over time, that volcano will continue to build and build and build, and eventually it will break the surface and we'll have a brand new Hawaiian island. So it's pretty amazing to see those kinds of features.
How long would that take?
About 1 million years. They find if
It's a long-term investment.
it's a long-term investment, yes. They find that between each island, it's about 1 million years between each island. So if you island hop, every time you move from island to island, it's about 1 million years between each one. All right, so I'm going to take you guys, we're going to kind of talk specifically about the Hawaii volcanoes. I just throw this slide in here mostly because I think that image is really pretty, and that is what we call a skylight. So going back to your lava tube question, underneath here is a lava tube, and the ceiling from this lava tube is actually collapsed in, and you can see the lava flowing underneath that. Then the far distance in that image, those clouds that you're looking at, are actually steam from the lava entering the ocean. They refer to that as ocean entry. And if you've been watching the news, ocean entry's been kind of a big deal because it does produce lots of things that we shouldn't be breathing in, bad chemicals, sulfur dioxide, carbon dioxide, all of that kind of stuff. And then just for a note, I always talk about the national park because I teach the national parks class on campus. Hawaii Volcano was actually set aside as a national park in 1916. The volcano itself that we're looking at, so Kilauea, the main volcano that we see there, has been erupting since the early 1900s. So they've been kind of watching that volcano erupt since the early 1900s. And in 1916, we set it aside as a national park. The park itself, which if you want to later on check out the map, and I'll show you a map up here in just a second, is only 358 square miles. Most of the eruption that you're seeing on the television, the stuff that we'll talk about at the end of the Lunch and Learn today, is actually outside of the park boundaries, but it is still monitored by all the professionals that deal with this, so the Volcano Observatory team, if you will. And I love this image, and I know it's not going to be awesome on here, but this is actually kind of if you were flying in a plane and looking side view at the big island of Hawaii. And you can see Kilauea Crater is basically sitting right down here. Maan Aloha, Mauna Kea, Hualalai, all of those things in the distance. So the reason I put this image up is to just kind of show you this is the kind of famous Kilauea Crater. That's the one that so many people go to in Hawaii, and you stand at the top and you look out. You know, we took students up there at night. You can actually see the red glow of the lava lake that's in the bottom of it. That crater had been erupting basically since the early 1900s. And in kind of like the 1950s-ish, they saw stuff in the crater kind of calm down, and all of a sudden they started to see all of these other little volcanoes pop up along what's referred to as the East Rift Zone. So if I pull this image back up for you guys, or I can do it up there too, the volcano itself actually has a big crack running down the side of it, and it goes to the east, and hence that it is referred to simply as the East Rift Zone. And the East Rift Zone is where we see all of these kind of subsequent volcanism kind of happening. So 1950s, 1960s, there were several eruptions. You can kind of see that gray shaded in area. Those were eruptions that happened in the 1950s, 1960s. And then all of a sudden, 1983, there started to see a large eruption just at the park boundary. And that eruption, again, you can kind of draw almost a straight line right through here. We call this the East Rift Zone. That eruption now has been erupting continuously since 1983. The volcano that's sitting way out here, they refer to as Pahoehoe, which if you teach kids, they think that's hilarious. But you guys are all adults and you don't find that as funny. But Pahoehoe is sitting out along that East Rift Zone and has been erupting basically since 1983 or so, until May of this year, where we actually started to see further cracks. And most of the eruption that we're going to talk about today actually is way over here on this map. So it's actually gone way off the tracks of that map. All right, I do want to, I mentioned to you guys the hotspot, and I just want to come back and talk about that hotspot and some kind of the history of it. So here's the big island of Hawaii, and then the islands trailing off of it. There's actually a ridge and a series of seamounts, and seamounts are these kind of eroded out volcanic knobs that are on the seafloor. They're not islands, they don't poke out. But you can follow that trail all the way up to the Aleutians. And you know, why do we care about that? Well, it's kind of cool because we can actually see the track of the hotspot. So about 45 million years ago, Midway Island, which is a pretty famous island, was actually sitting over the top of the hotspot. And basically from Midway all the way up to the Aleutians, the plate was actually traveling due north. Now, the weird thing to us when we look at this is that, remember, the hotspot doesn't move. The hotspot's sitting still, but those plates, the Pacific plate, is actually sliding over the top of it. So it's like that plate is getting a tattoo as it rides over the top of that, which, again, so we're seeing at least 80 million years worth of that history. Now, weirdly enough, between today and about 45 million years ago, the plate's now just drifting kind of northwesterly. And again, if you looked at the location of Lauihi, you'll notice that it was southeast of the big island of Hawaii, indicating that that plate is still moving in that northwesterly motion. So it's going to continue to kind of drag along and move that direction. I want to show you guys some images of the kind of inner workings of the volcano itself. I use these images with my national park kids to kind of show them what's going on. So zoomed in, here's Kilauea, the actual Caldera crater that we refer to. And again, hasn't had a big eruption basically since the 80s. And you might say, well, that's interesting, Kate, because Pahoehoe started erupting in 83. We're going to talk about why that is from this in just a second. On the surface of Kilauea, we see some of these things referred to as pit craters. And what's happening here, guys, is there's a huge chamber of magma below the surface. And that chamber of magma is constantly in flux. So sometimes it's inflating and sometimes it's deflating. It's like a big giant balloon underneath the surface, and it actually craters the surface of this. And then there's been some other eruptions. Maan Aloha, we see up there from 1960 to 1974. Not terribly important, but some of those mid-eruptions. There's that magma chamber. But here's the interesting part about that magma chamber. It's connected to that East Rift Zone. So again, there's a big crack in the side of the volcano, and magma makes its way up to the surface, and we can actually see what's going on. They actually measure the lava lake in Kilauea, and sometimes the lava lake in Kilauea is really high. And what we find is when that lava lake is really high in Kilauea, Pahoehoe, which is just down the road, nope, and one more slide, there's Pahoehoe. Pahoehoe is really inactive. And then all of a sudden there'll be a big switch, and the lava lake in Kilauea will drop really drastically, and Pahoehoe will have a huge eruption. And so we know that they're connected. We know that there's a lot happening subsurface. It's hard, and a lot of the scientists who work in Hawaii are trying to track all of the plumbing, if you will, that is in the volcano itself. But there's lots of things happening, and then, of course, Eventually, we have lava tubes, and of course that east rift now, what we're seeing is more eruptions basically happening down in this area, which you'll see in just a little bit here. So again, lots of different dynamics, lots of things happening just to get lava out. So again, that Kilauea has a large amount of lava sitting right beneath the surface. It's kind of interacting, it's inflating, it's deflating. It's definitely changing the surface of the island every day. So we see lots of monitoring happening there. And then, of course, eventually we do get the eruptions that are into the Pacific Ocean, and this is what's actually adding onto the volcano itself. And we get beautiful things like this image where we've got what they call ocean entry, where you can actually see active lava hitting the ocean. It dries very quickly, or it should say solidifies very quickly, and forms the actual hard rock that you see there. Sometimes people will say explosions are happening at that, and it's just because it's so hot and it's meeting icy cold seawater, and so that's what's generating those explosions. Also has lots of gas trapped within it, so that could be fueling a lot of those explosions as well. Very, very dangerous. A lot of times, and actually some of the Hawaii sites are telling people not to go near this right now because it is so explosive. They actually, was that a week or two ago, there was a boat that had an accident. They were too close. They shouldn't have been in that area, and there was a large explosion, and it did some damage to the boat and injured a few people. So the people of the United States Geologic Survey, the Hawaii Volcano Observatory, they actually map out safe boundaries where people can approach this, and the problem is people don't really listen and they go wandering into areas they shouldn't be wandering into. I mentioned lava tubes, so there's a big intricate plumbing system beneath this volcano. These gentlemen, they actually work for the USGS, are standing above one of these lava tubes, and that's a skylight, so you can actually see the active lava flowing through that. The temperature of the lava in there is in excess of 1,200 degrees Celsius, so very, very hot.
How hot is it on the surface there?
Very, very hot. If you were to leave something sitting on the rock there, it would probably start to melt. So when we were there, we didn't get this close. We went down to one of the kind of more active areas, and they told us we had to wear, and you'll notice these guys wear full cotton. You can't wear anything synthetic. If you wear something synthetic, it will actually melt. Shoes had to be Vibram-soled shoes, because you'd go walking across this hot rock, and if you were wearing flip-flops, it would actually melt your flip-flops. So you have to be pretty careful. The one thing we noticed is that, if you have jeans and they have a rivet in them, the rivets in your jeans heat up. And you can feel the heat coming off of it, so you've got to be very careful. Oftentimes, I don't know if I've got a picture of anybody in gear, but a lot of times when they're out near the real active stuff, you'll see them in heat repellent suits and things like that. Yeah, very common. Very, very common to see that. If anyone's ever been to Hawaii Volcanoes, the actual national park, this is Thurston lava tube. So this is an old lava tube that is solidified, and you can actually go hike around in it. It's all lit, very safe to go check it out. But this is what one of those lava tubes that plumbing system would look like. And again, for scale, you could drive a car basically through this lava tube. So it's kind of crazy to think about lava. There are a ton of these all over the island, and they're basically interweaving and kind of carrying that material around. Other beautiful things I want to show you dealing with Hawaii, and then we'll get to the kind of what's going on today. I always like to talk about the different types of lava that flow in Hawaii. So this type of lava flow is what is called Pahoehoe. And Pahoehoe is a Hawaiian word that means ropey or rolled over. And so I have a chunk of Pahoehoe here, and this happens when the lava is moving very slowly, and it actually curls back on itself, so it kind of rolls almost like bread would roll. And you'll pick this up and you'll notice the underside of it has that kind of gorgeous rolled over texture to it. So that is that beautiful Pahoehoe. And then We also see a different type of lava texture. This is what's called ah, and the joke behind ah is that if you had to walk across it barefoot, that would be the noise that you would make, because is very sharp and jagged. And so what's happening here is as the lava cools, it's slowing down, and it's almost shattering like glass would shatter. And so I do have a piece of lava here, and I'm going to tell you as this is coming around, be careful, because it does tend to be a little sharp, so just don't, scratch yourself on the lava flow. But that is a chunk of that's coming around as well. So go ahead.
Is that also white obsidian?
So this is actually basalt. Obsidian is volcanic glass. So if you think about where you were seeing ocean entry, a lot of times we'll find little pieces of obsidian with ocean entry, because obsidian only happens when we have instant cooling. So this stuff is taking hours to days to cool, and when we do that, we can actually get the texture of basalt, so igneous rock basalt. But when we get obsidian, volcanic glass requires millisecond cooling. So that stuff hits that water and instantly solidifies. In Hawaii, a lot of times you'll go places and it'll almost look like there's like straw over the landscape, and they call that Pele's hair. And what that actually is it's little tiny drops of glass that have basically gotten shot out of the volcano, and they got pulled along by the wind. And so it's not straw, it's actually glass, and the whole area will get paved in this, and it's really, you can step across it sounds like breaking glass, but you'll see Pele's hair all over the place in Hawaii. All right, so I want to show you guys one last image, because this is technically an out-of-date image, but I want to show you this just so you can see what's actually going on, because I'm going to show you another image of like what this looks like today, and you're going to go, oh my God, that looks totally different. This is Kilauea Caldera, so this is the top, this is the crater at the top of the volcano. And you'll see that it has these kind of steep walls, and that there's a little tiny lava lake inside of it. And they actually measure the height of that lava lake. Ever since this eruption started happening in May, that lava lake has completely disappeared. It's gone. We don't see that lava lake anywhere. So they actually think all the plumbing has pushed all the lava out to where the current eruption is happening. And so we see that Kilauea volcano. One of the things that this does, and this is one of the reports you'll see, is causes big collapse, because these walls are very steep and there's nothing supporting it anymore. There's not that lava pushing up against it. And so we see lots of collapse of that. And they've been reporting that, and they've been really concerned, because every time there's a big collapse, we get a big ash cloud kicked out of this, and then that is not so great for breathing purposes and all of that kind of stuff. So there is that. Okay, so let's talk about the May 2018 eruption that started, kind of what's going on all the way up to present. So the terribly sad thing about this is this eruption literally started like finals week for me, and I couldn't teach any students about it because they were all taking their finals and they wanted to run out the door as fast as possible. It made me a little sad. I'm okay though. So 585 new acres of land have been added to the island, and that number is actually off. That number is probably from about a week ago, so we're getting more island added on, and you're going to see some cool features here in just a second. The unfortunate thing is that we've seen over 700 homes destroyed by this. Some of you guys were talking earlier that people were talking about how cheap land is on the Big Island of Hawaii, and it is. In fact, there are large subdivisions that exist right here, and you can buy a house there for very, very, very cheap, because there's a really good chance that, the volcano could start erupting and basically take out your home.
But you still own the land.
You still own the land. According to Hawaiian law, you own the land that is now paved over the top of with your, you own it. All right, so we're going to zoom in. This is an image that's provided by the Geologic Survey that you'll see a lot today. So that didn't work. But here was that area of Hawaii. So this is the summit that we were talking about earlier. And here is where we're kind of zoomed into. So Kilauea is kind of this whole end of the island itself. And that's what we're kind of looking at here. So some areas that you're probably familiar with. There's no pointer in this room. But if you've been paying attention to the news, you probably heard a lot about Leilani Estates, because that's where this thing started. These rifts basically kind of popped up. And I want to show there's basically a line you could draw right across here. That's the East Rift Zone. So that rift goes all the way down to the end of the island, and all of those little numbers that you're seeing on here, 11, 12, etc., those are all rifts that broke open and were having an active eruption. They kind of come and go. They open up, they erupt out some lava, they shut down, they open up, they erupt out some lava. Currently, as of like yesterday, Rift 8 is what we're seeing all of the lava actually pouring out. So everything that you're seeing on there that is in that pink, that is from this last eruption. That's a lot of lava. And there are some of those other lavas that you're seeing on there, the purpley color. The one at the top is from an 1840 eruption, and then the Pahoehoe eruption from 1960. You can kind of see all of those different ones. So here's your lunch and learn moment. If someone comes to you and says, hey, want to buy some cheap property in Hawaii? You say no. Because this was a whole subdivision that was built, and you know the people knew they were buying on an active volcano, basically. Another cool image that I want to show you, and then I've got some other videos and things. So this is actually a thermal map. So they flew over with a thermal camera and took an image of this. And you can actually see, so this is Fissure 8. And the crazy thing, you might have seen images of people like standing in their yards videoing this thing. There's houses that are like right up to Fissure 8, and people aren't technically supposed to be going in by it, but you can see it pretty easily. It's relatively easily accessible, and it's just fountaining lava out. And the lava flow is actually coming all the way out Fissure 8. All that white that you're seeing is actually active lava flow coming all the way down, and it's actually doing ocean entry right along that area. So you're going to see some images of ocean entry along with it. So again, the idea here is this is active lava flow. It flows for miles and miles and miles. It does not care about what is in its way. We can't put up big berms to stop it or anything like that. And then here's kind of the overhead image. Again, in the far background, that little fiery bit that you see in the back, that's the actual fissure that's opened up. And then you can see this whole swath of active lava flow. There's a house there for scale. And again, if you've bought property there, you're just basically sitting on top of it. And then the last little image, and I want to show you guys some other stuff from their website. This was just reported on July 13th. So you can see the active lava flow moving into the ocean. A little island popped up. And this is probably because there's a lava tube that exits the island underneath the seafloor, and it's actually building up a tiny little island. Eventually that will get connected back into the mainland, but it's kind of cool to check out.
Is that little orange bit in the center, is that like a spout?
That's probably a little crack, a little crevice in the top, and it's fountaining to relieve pressure, I would assume. But that's what you're looking at with that. So that, I want to show you just a couple of other cool bits, and then of course I will take questions and all of that good kind of stuff. That is too giant for that screen. Hold on. So one of the, here we go. One of the websites that I use really frequently is the United States Geologic Survey. It's just usgs.gov. If you ever want to learn more about earthquakes or volcanoes, any cool stuff like that, that's the website to go to. But volcano.usgs.gov, super easy to remember, has all of the information regarding what's going on here. And I want to take you over to, okay, current alert is where we are, and you can actually click on the volcano, and it's actually telling you everything that's going on with that volcano right now, which I pretty much just did for you. I want to show you multimedia is where I want to go, I believe. Okay, so if I scroll down here, they've got some crazy cool images that have been kind of kept, but I want to show you, not that video. That's a gorgeous ocean entry shot that you're looking at. And then you can see the lava just actively flowing out of Fissure 8. That image right there, that's actually the fissure 8. That's the summit of where that eruption is happening. So you can see how close people are actually getting to it. Give me just a second. I know it's just down here. That's a gorgeous shot of here. This is an ocean entry video. These are like really high resolution videos, so sometimes they take a second. You can do it. Yeah, go ahead.
The volcano that erupted in Guatemala, is that like in a similar?
That is actually a subduction zone volcano that you see. Yep. So not too similar to that one. That one's actually due to subduction. All right, maybe our video isn't going to load today, but I've got some other cool things that I want to show you instead.
Did you like the sulfur smell?
You know, it's interesting because I didn't find it, you know what happened was we were staying basically on top of the volcano, and you'd wake up in the morning and your throat was scratchy. And you didn't necessarily feel that you had been like exposed to a lot of sulfur. You didn't necessarily, like your clothes didn't smell or anything like that, but you would always have a scratchy throat when you woke up in the morning. And they actually do VOG forecasts where they say, you know, like today's not a good day if you've got asthma or anything like that. So they actually do all of that.
Before the '83 eruption, there's a Kilauea military camp over there.
That's where we stayed.
Took my folks over there, and we stayed up there.
Mhm. Beautiful.
Mom and Dad really enjoyed it.
Yeah.
But yeah, even then the sulfur was pretty bad.
Yeah,
It's a problem.
the Kilauea military camp is basically just east. Yeah, it's just east of what they call the sulfur bank, and there's a huge bank on the side of Kilauea, and it just outgasses a ton of sulfur. So it always has that kind of rotten egg smell and steam. There's lots of steam that come off. So I apologize, guys. Apparently none of these videos want to load today, but there's some cool stuff that shows you. Oh, this is the video I really wanted to show you. I bet it won't work though. Oh yes, it's gonna work. Yes. So this is inside Kilauea, and I think this is so cool what they did. So this is actually taken with like a digital high resolution flyover that they did, but wait till you see they actually turn it sideways. And you'll notice when they do that, no lava lake. So this whole crater, right, you saw the image, this crater used to be this big, and because that lava lake is gone, that whole crater just keeps collapsing in and collapsing in and collapsing in. So we're actually making a bigger hole in the ground as we go along. But I love that video because I think it's so cool to see it. And again, no lava lake present there because most of the lava has actually moved out to this new fissure that's basically erupting. So constantly changing. We just constantly see different things happening in Hawaii. So it's almost like a daily to check in and see what exactly the volcano is doing. Usually people ask, well, Kate, will we ever get lava back in Kilauea? Probably. We probably will see in a few months that this fissure will shut down, and we might see a buildup of lava. It could continue just to flow out of Fissure 8, and we could never see eruption out of Kilauea ever again. Volcanoes are kind of unpredictable in that manner that we can't really tell what's going on in the plumbing system. That's a shot. This is just a photo of what Pahoehoe looks like. And usually you don't get a lot of good photos of Pahoehoe because it's usually got a lot of steam and gas coming out of the top of it. But that's the surface that's looking down into Pahoehoe. And it's really rare because all the lava is flowing out of Fissure 8. There's really not a lot. There's a little lava lake in Pahoehoe, but usually when I've seen images of Pahoehoe, there's like active lava pouring out of the surface of it. So that's kind of a random interesting photo to catch without a bunch of lava flowing out of it. I wanted to show you guys, there's a video on here that apparently I can't find anymore that was showing kind of how this whole Well, at any rate, can't get any of their videos to load, but you know what? You can go and hang out and have a great day watching a USGS video from your home computer too. Do you guys have any questions? I know it's about that time that I probably should take questions and maybe send people on their way if they've got to get back. Other questions you guys have? Anything about volcanoes? Go ahead.
I heard the glass, when it hit the ocean, like glass would come out, like glass particles.
Mm-hmm. Shatter, yep.
And how far inland does that go? Are people in danger of that?
You know, it's kind of confined right to that area, but they are still finding small amounts of ash that can actually get picked up by the wind and blown inland. And normally you'll find just like it'll appear like dust on everything. So dangerous. Depends. You know, people breathing that in, not so good for you. Any kind of like electronic motor that's sucking that in, like a car engine or your air conditioning unit, bad for that too. But we're not going to see ashfall like the Mount St. Helens ashfall. These kind of volcanoes don't produce that amount of ash when they erupt. So, go ahead.
I remember there was like some volcano that erupted like in the late 1800s, and they said that it caused a lot of global change.
Mm-hmm.
You know, is this going to be impactful?
So Krakatoa is the big one that erupted in the 1800s, and that was more of an explosive eruption, and the reason it had such a global impact on climate was because it kicked a bunch of ash into the atmosphere. Ash in the atmosphere kind of cools us out a little bit. Hawaii is not doing much in the way of kicking ash into the atmosphere. However, it is outgassing more carbon dioxide, sulfur dioxide, and that adds to what's going on climate-wise, if you will. So we do see kind of changes with that. Is it kicking out enough to see something really drastic happening? Probably not. You'd have to see a big crack open up for that. But we definitely do see increased CO2 and increased sulfur dioxide eruption from it. Go ahead.
You said that there was about 504 acres of land. Is that just right at the ocean?
Just creeping out. It actually, it filled in, I can never find, it filled in a lake, so you added land. There was actually an inland lake, and the lava just flowed right over the top of it, covered it all. And it's just adding on like you're seeing there, so it's just kind of slowly creeping outward and basically extending the edge. Actually, if I go back, I know I have this image somewhere.
Does it reach all the way to the ocean floor though, or is it more of a ledge?
It's more of a ledge. There it is. It's more like a ledge that you're seeing, and that's the dangerous. Here we go. So the danger in this is that it kind of grows out. It creates kind of a false beach, and then the lava kind of builds up on this false beach. And it's going to get to a certain height that false beach can't handle it anymore, and it will actually crumple and fall into the ocean. If you've ever been to any of the other Hawaiian islands, you can actually see this on Oahu. I can't think of the name of where it is, but you drive up the side of a cliff, and you can actually see the whole island actually slid down sideways. But on this image, you can see the old coastline is actually that little area that's drawn in there. So everything added onto that is extra land, basically, that got added on. So that's all of that additional acreage that you see there. So, go ahead.
Now, eventually, a lot of that will cool off. And how long does it take for plant life to come back?
So the big island, like if you were to go up to like Kohala, there's already plants growing, and this is less than 1 million years old up here. If you go up Mauna Kea or Mauna Loa, they're still pretty barren. They're relatively young. The top of Kilauea, still pretty barren. You'll see there's a plant called a silver sword. To me, it kind of looks like an aloe plant, but it's some member of the cactus family, I believe. Silver swords can grow really quickly on this kind of desert environment, but most of the island of Hawaii, the big island, is almost desert-like because there's not a lot of green. The north part of the island is green, but once you get south on that island, you lose a lot of the greenery from it because it's rock. It hasn't degraded into soil yet. But then if you island hop, if you've ever been to Maui, people who go to Maui say, oh my God, Maui's gorgeous, it's green. It's about 1.5 million years old, and so that sediment has broken down and it's created great, really, really great, very lush organic soil that these plants can grow in. So as you kind of move along, the Hawaiian Islands get greener. The oldest island is the greenest island. So
what causes the sediment to break down?
Just natural. It's, to be honest, the rock, this basaltic, that dark colored rock that came around, it's not very stable in these kind of pressures and temperatures. And so it tends to just naturally weather out. Hawaii is a moderately humid climate. They get lots of rain. That rock doesn't do well in water. Tends to break down, tends to disintegrate into soil pretty quickly. So,
That's why we got the black beaches.
and the black sand beach is just the erosion of that. There's a green sand beach where you can go to and see green sand. Yeah, we got to go to the green sand beach. I can find it on this map for you. But the green sand beach is kind of down in this area, and it's actually eroding out an old little volcano, and it's all green sand as you walk across it, so you can see. 2000, okay, so let me think. 3 years ago and 5 years ago? I've been twice now. I think it was 3 and 5 years ago that I've gone. Before any of this ever happened. And now I want to go back. We do joke. My friend who leads the field trip, every time that I've gone to Hawaii, Pele has thwarted me because I've never gotten to see ocean entry, and that's like the one thing as a geologist that you want to see. And every time I've gone to Hawaii, the lava flow, so the East Rift Zone is kind of this crack, and if lava flows down one side of the East Rift Zone, it goes to the ocean, and we see ocean entry, and that's amazing. But if lava flows down the other side of the East Rift Zone, it flows into yeah, and you can't see ocean entry, and so that's a bummer that you can't see ocean entry. But yeah, so I've never gotten to see ocean entry, but I really want to go back and see it. And now that all of this has changed, it'd be pretty amazing to go and see, especially to see Kilauea, just the surface of it looking so different. Because we were there, and there was actually a lava lake there, and that was pretty neat to see.
Okay, I just want to ask you about you mentioned on the Native Hawaiian culture calls it Pele, right?
Mm-hmm.
And so what's their explanation for the hotspots? You don't have that.
Their explanation is that Pele is stoking that fire to keep the fire alive. So it's interesting, Hawaiians have, their culture is really cool because they have an explanation for just about everything, and it's all, on these different gods and goddesses, Maui pulling the islands out of the ocean and all of that kind of stuff, and slowing the sun down so that they could actually get those gorgeous sunrises. But their explanation is that Pele lives inside of the volcano, and she is stoking that fire to keep that fire burning. So that's what they think. They also have, I can never remember her name, but there's a goddess who lives on Mauna Kea because Mauna Kea is snow covered, and she actually has icicles in her hair and stuff like that. And she's a sister of Pele, and there's they have a disagreement over a man, and they pose a race to each other. And Pele thinks she's going to win because lava can flow so fast downhill. And then the goddess with the snow hair, who I can't remember for the life of me, she actually wins the race because she ices everything and goes all the way down to the ocean. And then Pele punishes her and tells her that she has to live on top of that island for the rest of and Pele, if you read Hawaiian culture, Pele is the sorest of sore losers. If she gets mad about something, she just burns a whole village to the ground. And that's their take. They're like, don't make Pele. If you go to Hawaii, if you go up to Kilauea, you'll see little gift offering stations all over. And when we were there, we actually took a bottle of tequila and poured it into the volcano because we were going to be taking rocks off of Pele, and you're not supposed to do that. But if you offer her a gift, and apparently she loves tequila, if you offer her a gift, you're free to take that stuff. So knock on wood, you guys all touched something from Hawaii, and we haven't had any problem yet. So, but you'll see all these little like offerings of like food and alcohol and little things set up for Pele, because they're serious. They take Pele very, very seriously down there. So, she looks not like the kind of person you'd want to. I mean, she basically has Pahoehoe for hair, so I wouldn't mess around with that either. But, so yeah.
White eyes.
So, other questions you guys have? Thank you so much for coming. I really appreciate that. And thank you. If you want to see the up-close map, I think this is kind of a cool map because it actually has the topography on it. So when we hit the lights, if you guys want to see it, and we can kind of point out where the current eruption is taking everything, this is a fun map to check out too. So thank you, thank you, thank you.